Okay, here we are, chapter 11. We're going to do rational equations and functions. As you can see, we're not going to do all the lessons. We're going to skip 1 and 2 and start up on lesson 3, and then do 3, 4, 5, 6, and 7. So make sure you're putting your name on the packet. So getting started, what we're talking about here is a rational expression, and it's an expression that can be written as a fraction whose numerator and denominator are polynomials. So all the way back to chapter 7 when you learned about polynomials, values that make the denominator of the expression 0 are excluded values. So we will talk about those. So the key idea for simplifying, when we put it in simplest form, we have the numerator and denominator with no common factors except for 1. And to simplify an expression, we will factor the numerator and the denominator and then divide out any common factors. And I just kind of wanted to show you this real quick here. For algebra, it's saying, let A, B, and C be polynomials. Where B and C are not equal to 0. And B and C cannot be equal to 0 because the denominator cannot equal 0. Okay? So you have A times C, B times C. Obviously, the C's could cancel. The simplified form would be AB. Here, right, it's factored in the numerator. And so what the common factor is the expression x plus 1. So when you cancel that, because it's equal to a fraction equal to 1, you're left over with this 2/5. Now, in the denominator, x plus 1 cannot equal 0 because we cannot have the denominator equal to 0, and so that's why x cannot equal -1. Also, looking at this would be like if you started out with 2x plus 2 over the 5x plus the 5. So sometimes you'll see expressions like that and you'll think, oh, there's nothing to simplify. However, you can see that in the numerator, you're factoring out the 2. In the denominator, you're factoring out the 5. That's how we get the common factor of x plus 1. So we're going to have to be very careful and make sure that we're putting things in factored form if necessary. Okay, so the example from the textbook, they're saying to break it up. I probably won't show my examples like this. I would do things like, make sure that it's on a pen here. I would say, oh, that goes into 12. When you divide them both by 2, then there's no x's in the numerator. So that's how you get your 6 in the numerator and your x squared in the denominator here. And then, of course, tell what your excluded value is, and it's 0. For b, n over n plus 8, no common factors. If 8 had an n and we could factor out an n, we could cancel 1. But n, and if you're having trouble deciding what it is, you want to make n plus 8 equal to 0 because it cannot be, right? So then if you subtract 8, that's where you're going to get this n is equal to -8. A lot of times I will write it like this, like n cannot equal -8, because that's the part that is excluded. Finally, here, again, it's already in factored form. The 3 and the 6, 1 and 2, and then this y and one of the 2 y's here. But this is an expression, and since there's no expression y minus 7 in the numerator, this has to stay in the denominator. And then when you go back and you look at your answer, and we're looking at the excluded values, we have to look at the original first, right? There was these 2 things. So this cannot equal 0, and this cannot equal 0 because of the 0 product rule. So for 6y to equal 0 is when y is equal to 0, and when y minus 7 is equal to 0, that's when y is equal to 7. So those are the 2 excluded values, and a lot of times we have more than one excluded value. So let's give some of these a try. Simplify them, and if possible, and then state excluded values. So the 5 and the 2, nothing to cancel there. There's 3 y's here, 2 y's here, so both of these could cancel, and it would leave 1 y there. So we would end up with 5 5y divided by 2. The excluded value is going to be that y cannot equal 0 or y is equal to 0, however you want to state that. But that's definitely telling you we do not want y to be equal to 0. Here, there's no expression x plus 1 in the denominator, so we want to factor out, let's see, this x will cancel one of these x's. 8 and 12 have a common factor of 4, so we could go ahead and simplify, divide by 4, divide by 4, right? So now we're going to have what's left. 2 times the x plus 1 in the numerator and 3x in the denominator. And again, we do not want x cannot equal 0. That's our excluded value. Okay, looking at number 3. There's nothing to factor out in the numerator. It's already in simplest form there. And it doesn't match this factor, and there's no extra m, so it is already simplified. So already in simplest form. The excluded values, though, this m cannot be equal to 0, and m cannot be equal to a negative 3, because negative 3 plus 3 would be equal to 0. So neither one of these parts could be 0. All right. Now we're getting to the part where, so the first ones we did were already given with factored form. Now we get to do the factored form. So we look at the numerator, and we could definitely factor out a 2. So let's go ahead and do that. And so we get b plus 4. In the denominator, we can factor out a 7, and we'll get b plus 4. So that the common factor then is the b plus 4. So this is what we are canceling, right? Common factors. So our simplified form is 2 over 7. Again, this is, we factored out the 7. There's no variable with that, so really it's just the b plus 4. So you always want to look at the original one. You could also do 7b plus 28 equals 0 and go through that whole process, but when we factored out, there's no variable here, so we don't have a 0, but we know that b cannot equal negative 4. That's the excluded value. Okay. For number 5, we want to factor out 2 in the numerator. I'm just going to do it right above it. So we'll get a minus 3. And then in the denominator, we can factor out a 4a. And so when we divide by 4a, right, we will get, a is what's left, and then 12a minus, divided by 4a, minus 3. So this is our common factor right here. Now, is this simplified? No, because 2 and 4 can be simplified to 1/2. So we'll get 1 over 2a is our simplified. And then here, I like to look at it maybe in this form, because we have this 4a and we have this a minus 3. Okay? So we would have to say that 4a could be equal to 0 or a minus 3 equal to 0, and therefore a cannot equal 0. A cannot equal the 3. And those are the 2 excluded values for number 5. Number 6, we have to factor the numerator. So if you can recall, this is, we did factoring in chapter 7 as well. And so we have factors of negative 16 that will sum to a negative 6. So you start looking at, 16, and the one that, comes to mind right away is 8 and 2. And since it's a negative 16, one of them is negative and one of them is positive, which means between the 8 and the 2, we'd be finding the difference. That's where we get the 6. Since 6 is negative, the 8 had to be negative. So we would have, go ahead and switch back to blue. We would have z minus 8 times z plus 2. Now I'm going to reverse these, right? Because I want to write this denominator. So I have this 8 minus z, but I could also write negative z plus 8. And if I do that, I could also factor out a negative 1, okay? So I reversed these, right? To put it in the standard form, variable first, but the variable is negative. So negative z and a positive 8 plus 8. Now I can factor out a negative 1, okay? And I have z, because it was negative, now it's positive, and then positive 8 goes to negative 8. Now the factors I can cancel are here. Now, I'm basically taking the opposite of z plus 2. So I get negative z minus 2 as my simplified form. Okay, now what I'm going to do is write my excluded values. And when I'm looking at my excluded values, I have z minus 8. There's no variable here. So z cannot equal 8. That's the only one that's excluded because I cannot have 0 here. So 8 minus 8 would make that a 0. Okay, so pause the video if you need to. I'm about ready to clear it. Move this out of the way. Now we're talking about the surface area to volume ratio of a cubed shaped substance with a side length of 2x. So when we're thinking about a cube, and I'm not really good at drawing these, so I'm going to do my best, but it's going to look like this, right? Okay. And if the side length is 2x, so then we know that we're talking surface area to volume ratio. That's what we're going to look at. For surface area, we're going to take the area of each side, which will be the 2x squared, and then, right, because 2x times 2x, and then I'm going to multiply that times 6, because there are 6 faces. So we have our 2x squared times 6, basically. Just writing that out just because I know I need the area of one of the faces and then that times 6. When I'm doing the volume, I basically have the length, the width times the height, and they're all 2x. So I basically have 2x cubed. So if I go ahead and I get, 4x squared times 6, I'll have 24x squared, and 2x cubed is 8x cubed, and this is what I'm simplifying. So 2 x's can cancel, and it'll cancel to 1x in the denominator. The 8 goes into 24 3 times, and so I basically simplify down to 3 over x. And my excluded value would be that x cannot equal 0. So this would be my final simplified surface area to volume ratio after calculating it. And we're all ready to the vocabulary and concept check. That was pretty quick. So select the one that you are answering, make sure you identify it, make sure you use complete sentences, and of course, if you have any questions, please let me know. Have a great day, and I'll see you tomorrow.